Okay, here's a problem where we're told we have a 100-kilogram block on which the gravitational force is 980 newtons and it hangs on a rope. And so we have a couple of scenarios here. One is that the block is stationary. Another is that the block is moving upward at a steady speed of 5 meters per second. And a third, the block is accelerating upward at 5 meters per second. So the interesting thing here is, let's see, stationary in this case, steady speed in this case, and accelerating up in this case. Okay, so what we're going to do is I'm going to draw a picture. So I'm going to start with A. Here I'm going to do the block is stationary. So let's write over here our givens. So our givens, mass is equal to 100 kilograms. The gravitational force, so that is F sub G. That's equal to 980 newtons. Okay, and so what I have to do is I have to find free body diagrams and the force of tension for each. Okay, and I know for A we have the block is stationary. So if I draw a quick picture, I know I have a block on a rope. And I'm going to draw my diagram, my boundary right here. So I've got this boundary, right? And the block is hanging. So since the block is hanging, there's no normal force. There's no compression force of the ground. The only thing that's acting on the block is my force of tension, because that's touching, contact force. So that's my force of tension and my gravitational force. There. So then I'm going to bring this over here to a free body diagram. Put my block at the center of mass of my block right there. And this is going to be my force of tension. This is going to be my force of gravity. Because it's stationary, I know it's not moving up or down, so I can't be accelerating. So these two arrows are the same, they're equal length. And so now what I'm going to do is I'm going to take my model. So the only forces here are only in the y direction. So I know my sum of the forces in the y direction. Since it's not moving, it's also not accelerating. So the sum of the forces in the y direction are equal to 0. The sum of the forces, so I take those right from my free body diagram. So I've got a force, the force of tension, and I have the force of gravity. So my force of tension is up, and I'm going to say up is positive. So that's my first component when I put these components of force into my sum. And then the second one is the force of gravity. That's equal to 0. So the force of tension is equal to, I add Fg to both sides and I get force of gravity. And so the force of tension, they tell us in our givens that the force of gravity is 980 newtons. So I know that the force of tension is equal to 980 newtons. So that's my answer to A. For B, I have the same boundary here, and I actually have the same free body diagram. So I have the force of tension, I have the force of gravity. There are no other forces acting on it. So I know it's, and why do I know that? And that's because it says that the block is moving upward at a steady speed of 5 meters per second. So it's moving, but because it's not accelerating, I know there are no net forces on it. So I know my net force, F sub net, is equal to 0, just like up here, F sub net is equal to 0. So my net force is equal to 0. So here, the same thing I do, the sum of the forces in the y direction are equal to 0 because F net is equal to 0. So I have the same exact problem, right? Force of tension minus force of gravity equals 0. Add Fg to both sides, so I get force of tension is equal to Fg. And so force of tension is equal to 980 newtons again. And that's because there's no forces acting on it. Right, but C is a little different. So we'll do C over here. So here I have C, the block is accelerating upward at F equals, or at A, the acceleration is equal to 5 meters per second squared. So if I draw my free body diagram, I'm going to have force of tension. And now I know my net force, so I have a net force up, F net. Right, so that means that I should have a bigger force of tension than I have the force of gravity. So I'm going to make my force of gravity a little smaller than my force of tension. So you can see the force of tension arrow is longer than my force of gravity. I have an F net that goes along with an acceleration, right? Anytime I have a net force, I'm going to have an acceleration. So my model, I'm going to have F sub y, sum of the forces in the y direction, equals, it's either 0 or ma, and since we have a net force, we have an acceleration, so we're going to have ma. I have the same forces, so I'm still going to have force of tension up minus the force of gravity down is equal to ma. I'm solving for the force of tension, so I'm going to add force of gravity to both sides. So force of tension is equal to ma plus the force of gravity. So force of tension is equal to, my mass is 100 kilograms times the acceleration that they tell me about in C is 5 meters per second squared, plus the FG is still 980 newtons. So when I add those together, 100 times 5 is 500. So I have 500 kilograms meters per second squared, that's Newton, plus 980. So when I add these together, I get force of tension is equal to 1480 newtons.